Okay, good morning, calculus students. This is May the 13th. Switch off the marker, which you can't see. May the 30th, 2014. I would like to thank Mr. Walter for coming in to help us. Your job today, Mr. Walter, will be to translate, if possible, anything that the students have questions on, and more importantly, pause the video when I say pause. I'm going to put 3 examples on the board for the class to try today. One demonstration, then, 3 examples after that. For each example, please give Mr. Walter about 2 minutes or 3 minutes so people have given a solid attempt and continue on. Okay? So this is going to be more complicated exponential derivatives. Okay, and the note today is just going to say you can use the product quotient, chain rules and combinations for exponential derivatives as well. Okay, one of the things we're trying to show in this course is that functions will work the same way. If you take the derivative of a polynomial or a sinusoidal, or you should also be able to do the same thing with a exponential as well. So the same thing we'll be able to graph and all that in a few minutes too. Okay, from yesterday, Rita, I'm going to pick on you. Oops, let me see this. Rita, I'm going to pick on you. I'm going to say from yesterday. Read if f of x was equal to b to the x, what was f prime of x, please? Okay, good. So you said ln b times b to the x, which is correct. All right, and Austin, if f of x is equal to e to the x, what is f prime of x equal? Okay, good, e to the x. Very boring, but very true. Okay, so we're going to just crank up the difficulty here a slight little bit. Whatever, it's actually not. If you take the derivative of all of these, you're also going to take the derivative of what the exponents are, like in a chain. So if in example 1 I do, if f of x, I'll start with an easy one, equals e to the 2x. 2x squared plus x. Let's go for that. Find f prime of x. Okay, I will take the class through this one, Mr. Walsh. You can let them sit through this one. If I'm going too quickly, please someone stop. Otherwise, we'll continue. So basically what you can do, if you do substitution, anything you sort of want to do, it's basically going to be for the derivative of this solution. I'll do it up here on the next board so everyone can see. So for my solution, this is going to be a chain. Okay? So we're going to set u of x is equal to 2x squared plus x. Okay? Robbie, I'm picking on you. What is u prime of x equal to, please? Wonderful. 4x plus 1. Okay. So if I have f of x is equal to e to the 2x squared plus x, can someone please be brave and let me know what f prime of x is going to equal? Unbelievable, Melody. I can see through space and time and you're raising your hand right now. What is f prime of x going to equal? Okay, very good. It's going to be e to the 2x squared plus x, then times the derivative of the brackets, which is 4x plus 1. Okay? All right, I have 3 questions for you to try, each of more increasing difficulty. Hopefully I will be back by that time. If I'm not, Mr. Walsh, you may have to tell some jokes or something. No, in all seriousness, it'll be about 15 minutes, so you should be back by then. Any questions on that? Clearly there's silence. If there is a question, Mr. Walter, can you explain, or can someone from the class try and field it? Thank you. Let's do example 2 here. Here we go, example 2. If f of x equals 4 to the 3x, oh, let's go crazy, of sine x, what is f prime of x? Okay, Mr. Walter, if you can hit pause on the video right now and give the students a few minutes to try this out, and then we'll see what happens. Okay, great, thanks. All right, let's start with the numerator here. Michael Sweeney, I have u of x, which is going to be my exponent. It's going to be 3x times sine x. Can you be brave, please, and tell me what u prime of x is equal to? Okay, good, so that's 3 sine x. Good, plus 3x. Oops, mistake, Mr. Sadler. Oh, that's right. Plus 3x cosine. If you want to factor into 3, go ahead. I'll probably will because I'm a math teacher. I like factoring. 3 times sine x plus x plus cos x. Okay. So far, so good. Let's pick on, how about Veronica? Veronica, can you try and give me what f prime of x is, please? Okay, I hear her saying, I don't know. I'm sorry, Veronica, if you know the answer, but let's pretend you say I don't know. Okay, let's pretend it was 4 to the something. What would the derivative of 4 to the something be? Yeah, good. So it's ln 4 times 4 to the 3x times sine x. Then what you're going to do is you're going to times that by the derivative, which is 3 sine x plus x cos x. Okay. So you're probably, what you're saying is, oh, you're right, that's not looking nice. Okay, but that's what that derivative is going to be. Are there any questions? So the original, if it's 4 to the x, if the regular 4 to the x, it's going to be ln 4 times 4 to the x. In this case, because the exponent was more complicated, it's ln 4 times 4 to the messy exponent times the derivative of the exponent. All right? Okay, example 3. Now let's go a little wild, shall we? If f of x is equal to e to the x squared divided by x plus 1, what is f prime of x? Okay, once again, Mr. Walter, if you can hit pause right now, I would greatly appreciate it. And then I'll give the class a few minutes to try this out. Okay, thank you very much, Mr. Walter. Let's do a solution here. Okay, Megan Little. Here I'm going to set u of x equal to x squared over x plus 1. Megan, can you try and give me u prime of x? Okay, it's going to be the derivative of the top, which is 2x, good, times x plus 1, minus, okay, good, 1 times x squared, all over x plus 1 x squared. I'm maybe going to neaten this one up because I think things might work out a little nicer for me. So I'm going to call this 2x squared plus 2x minus x squared all over x plus 1 squared. So I'm going to say that u prime of x is equal to x squared plus 2x all over x plus 1 squared. Okay. All right, so that's just quotient rule what I use there. Okay. All right, are we feeling good? Matt, all's well? Okay, Reed, all's good? All right, this is where I would insert a joke right now, but I'm going to be honest, I'm not feeling that funny at the moment, so I can't. Mr. Walter, if you want to hit pause and throw a joke in there, you can. This is also where I tell Reed to get back on task because he'll be looking at something on his phone. Math related, Mike. Okay. Wonderful. Okay, so let's actually get to what the equation is going to be here now. After all this, I'm going to pick on, who's it going to be? Robert is going to be my victim here. Okay. What's the derivative going to be? Okay, the derivative of e to the x is just e to the x. So the derivative of e to the something messy is going to be e to the something messy, which is x squared over x plus 1, times the derivative of the exponent. So times x squared plus 2x all over x plus 1 squared. That's probably almost enough time, but just because I'm feeling a little crazy tonight, tonight being, it's actually, if you really want to know, it's 12:35 the day before, but that's okay. Example 4 will be one final one. Let's do, yeah, let's go crazy. 2 to the 3x minus 1 times 3 to the x squared plus 9x. Yeah, all squared. Okay, this, my friends, is the most difficult derivative I can think of. Okay, so I should probably, I can't actually edit this, but if I was gonna, you know, it's still Mr. Sadler recording this, because I do this every day. Okay, so I'm gonna let f of x equal to that. Okay, now the question is, before you start, is how to do this. There is going to be a chain and then a product and then a few more things here. Okay, so I would probably set lots of variables here. The nice thing is the exponents inside won't be too bad. I'm going to ask Mr. Walter to hit pause, or Mr. Sadler if I'm back by now, and we'll do it as a class. I'll give you guys a few minutes to try and we'll do it. All right, thanks, we're back. Here's my solution. Okay, so what's going to happen is, this is going to be a monster. I think it's so big I might just go to, I'm not going to kid around, I'm just going to go to 2 boards right away. I'm going to say f prime of x is equal to, I'm going to take this 2 and bring it down. I'm going to use a giant chain. Okay, then times the derivative of the inside. The derivative of the inside will be a product rule. So next I'm going to take the derivative of this. Okay, I'm going to pick on, who am I picked on yet? Dakota, what's the derivative of 2 to the power of 3x plus 1? Okay, good. Ln 2 times 2 to the 3x minus 1 times 3. Then what you also have to do is you have to times that by 3 to the x squared plus 9x. Okay. Since the product we're going to be adding, which I'm going to be doing this one right now. Courtney, I've left you alone all day. Can you please take the derivative of that for me, please? It's going to be ln 3 times 3 to the x squared plus 9 x times 2x plus 9. And I'm still going to times that by 2 to the 3x minus 1. Okay. If that equation doesn't make your toes curl, probably nothing will. The question is here, what's common? Okay. What I'm probably going to try and do here, there's not really too much. I could probably do a little bit of factoring. There's probably not a huge amount that I can factor. I'm trying to think how far I'm going to make take this. I see common factors. I think we're going to take up some common factors. The common factors I'm going to see are going to be 2 to the 3x minus 1. And 2 to the 3x minus 1. So that's going to come out. Also, I see a 3 to the x squared plus 9x. And then the leftover part, which is going to be 3 times ln 2 plus 2x plus 9 times ln 3. Okay, this can still be neatened up. If I was saying, Mr. Sadler, I wish we would just quit. I will not. Okay. I'm going to call this 2 times 2 to the 3x minus 1 squared, 3 to the x squared plus 9x squared times 3 ln 2 plus ln 3 times 2x plus 9. And that is pure beauty. Okay, Mr. Sadler will be back right now. Thank you, Mr. Walter, if you're still here. If you're not, thank you very much. That was a wonderful question. That derivative we just took is to a level of 10 out of 10 difficulty. Let me rephrase. It will be on your test. Okay, so that would be like the hard derivative on your test would be this one here. Okay? All right, thanks. See ya.